Okay, so good afternoon, everybody, and welcome to F1 Math. And today we're going to be working with travel graphs. Okay, so what is travel graphs? Travel graphs are also known as graphs of motion. The graphs that is dealt with in this section are limited to graphs of distance, as well as distance on the vertical axis and time on the horizontal axis. Remember, the gradient of a graph is equal to the speed of the graph. The gradient of the graph is equal to the speed of the graph. So that means the steeper the slope or the gradient of the slope, the faster the object is traveling. I'm going to repeat that. The gradient of a graph is equal to the speed of the graph. So that means the steeper the slope or the gradient of the slope, the faster the object is traveling or moving. This means that a straight line which has a constant gradient shows a constant speed. Okay, it means that a straight line which has a constant gradient shows a constant speed. So if the graph is a horizontal line graph, then the object is not covering any distance. It is remaining stationary. Okay, so if the graph is in a horizontal line, that means the object is not moving. It is a stationary object. Okay, so we're going to work a little bit with some examples. An object with a distance of 0 covered is still at the same place. So wherever it starts, it's going to be standing still because it is not moving. It's in a horizontal line. I'm going to draw for you sort of graph. Bear with my drawing. Okay, so if this is my graph and I have distance and I have time. Okay, now so let's go with blue rubber. Okay, so if my graph started at the bottom, it went up and then did that, okay? And then another line did down the middle and then suddenly did that. What it means is that the line shown above is a motion of a car. These two lines represent the motion of a car. Okay, so if we look at the red one, for example, it shows us that the car starts off from a rest point. Can you see? It's sitting at a rest point. The car starts off at a rest point and then stalls. And we can see this because we can look at it on this horizontal axis. Okay. And it doesn't cover any distance, because if it covered any distance, it would be traveling upwards. Okay, so it's stationary or it's in a rest point here, and then it stalls. And then it does the first period of travel. Okay, and it starts and it covers a distance at a constant speed. Okay, for the rest of that graph. So the red one starts off at it starts off on a rest pose, it stalls, and then it carries on a constant speed all the way to the top. Then let's look at the blue line that I've plotted on that. The blue line shows us what? The blue line shows us that the motion of the car starts off immediately. It takes off immediately, and then it stops. It starts off immediately, and then it stops. Okay, and then it gets to the point where the red car actually overtakes it. Okay, it stops, and the red, if this is the red car and that's the blue car, the red car overtakes it, okay, and moves up and travels faster. Then it takes off, it stays in one motion or in a rest motion, and then it takes off and then it travels faster than the red car. The motion of an object can be displayed on a distance time graph. Okay, the motion of an object can be displayed in a distance time graph. If an object is traveling at a constant speed, the distance time graph is a straight line. I'm going to repeat that. If an object is traveling at a constant speed, the distance time graph is at a straight line. For example, I'm going to clean this out and share with you a screen. So for example, if we look at this particular graph, okay, the distance time shows us the object moves all the way up to 240 kilometers, okay? It shows that the object is moving. It's moving, okay? And it shows us the time it takes to get to the place it's getting to. So when we work out this, how would we then work out the distance and the time for this? What we will then say is 200 and the speed is, okay, not 200, the whole thing. Its speed is equal to 240 over 60. Okay, and if we calculate that, speed will therefore equal to 4 meters per second. Okay, if we divide them. So that's how we would work out speed and distance. Now, let's go on and let's try and do an exercise. With your textbook, I've got your F1 math textbook, and I am on page 50, and I'm going to be doing exercise 11.2. Okay. And I'm just going to quickly share the graph with you so you okay. So just if you can look at this graph for me momentarily, it shows distance, it shows time, and now we're going to answer some questions based on this particular drawing, okay? So I'm going to remove this drawing so I can work out on this board. So if you're following with me, I'm on page 50. The first question asked on this travel graph is, what time did the family set out? So let's look at this drawing for a moment. What time did the family set out? The family set out at 7, no, sorry, I'm on the wrong screen here. It's stop sharing. The family set out at 7:30 a.m. Okay, can you see that? So reading this graph, it tells us the family set out at 7:30 a.m. Then it asks us, how far did they travel in the first half an hour? So in the first half an hour, so that would be they traveled 60 kilometers. Quite right. Okay, they traveled 60 kilometers in the first half an hour. What was the average speed they were traveling at? Who knows what was the average speed they were traveling at? They were traveling at 120 kilometers per hour. Okay? The next question says, what time did they stop for breakfast? Now, when did they make their first stop? They made their first stop at 8 a.m. Because if you look here, this is where they stopped for the first time. Okay, the next question says, how long did they stop for breakfast? Now, can you see the period between when they stopped and when they started again? So how long did they stop? They stopped for 30 minutes. The next question asks us, how far did they travel between 11:30 a.m. and 8:30 a.m. and 11:30 a.m.? So how far did they travel? So there's 8:30 a.m. here, and that's 11:30 a.m. How far did they travel? Okay, they traveled a total of 40 kilometers, okay? Number 6 says, the average speed is calculated by dividing the total distance traveled by the total time taken. calculate their average speed during 2.5 hours. How would we go about doing that? Okay, I'm going to clear out my board so I can show you how we go about doing that. Okay. Okay, so the average speed is calculated by dividing the total distance traveled by the total time taken. Calculate the average speed during those 2.5 hours. So, firstly, we know the distance is 40 kilometers. Okay. We don't know the speed they were traveling at, that's unknown. But the time they took is equal to 2.5 hours and 30 minutes. Okay, so now how do we work this out? Firstly, our 40 kilometers becomes 4,000 meters, and our 2 hours and 30 minutes becomes 9,000 seconds. Okay? And so now we divide the two. We say distance over time, because that's how we're going to work out our speed. So we're going to say 4,000 over 9,000, and you should get an answer of 4,44 m.s minus 1. Okay, and that would be your answer. So that would be the average speed that it took during that 2.5 hours. Okay. Now, number 7 says, the family reached a motorway at 11 a.m. What was the average speed for the next hour? So the family reached the motorway at 11 a.m. What was the average speed for the next hour? Okay. Yes, guys, you'll be allowed to use a calculator to work with this. So what was the average speed that they were using on the motorway for the next hour? So let's do that. So that will be for the next hour. So we got time is equal to 1 hour. Okay, and the distance was 100 kilometers. Okay, now the time is 1 hour, but we need to convert that into seconds. So this becomes 3,600 seconds, and our 100 kilometers becomes 100,000 meters. So then we say distance over time is equal to 100,000 over 3,600, and if we divide them, of course, guys, using your calculator, speed is then equal to 27 ms minus 1. Okay. So, if we have to have a look at this, guys, before I continue, you guys do understand why it's ms minus 1, yes? When we're dealing with speed, the unit of measurement is m.s, okay? So we're dealing with it, it's m.s. And the power to the power of 1. And in this case, it's to the power of -1. Okay, now let's move on to number 8. It says, how long did the whole journey take? So if you go back and look at your graph, the journey started at 7:30 and ended at 11 a.m. and then how long did the whole journey take? The whole journey took 4 hours and 30 minutes. Okay, so if you calculate the hours, you will see that the journey took 4 hours and 30 minutes to complete. The next question says, how far did they travel in total? So looking at your map, at your graph, how far did they travel? Okay, if you look at your distance part of your axis, it will tell you exactly how far they traveled. They traveled a distance of 200 kilometers. Okay. Number 12, what was the average speed of the train? Okay, so no, it says the second family sets out on the same journey by train. They leave at 10:30 and arrive at noon. Show this journey on your graph. So a second family is now traveling on the same trip. They're on train, they're not in a car, and they want you to show this journey on your graph. So when you show this journey on your graph, what will it look like? Okay, firstly, we know that the family is on the same trip. They're leaving at 10:30 and arrive at noon, which is 12 o'clock. And then the first family left at 7:30. So you can work out the difference between the two. Okay, I'm just going to do a quick recap of what we actually did right now. Okay, so we spoke about graphs and we spoke about travel graphs, and we said that the travel graphs are also known as graphs in motion. Okay, we said that the graphs dealt with in this section is limited to distance, which is on the vertical axis, and time, which is on the horizontal axis. And we said that the gradient of the graph is equal to the speed of the graph. So that means the steeper the slope or the gradient, the faster the object is moving. Okay. This also means that that a straight line which has a constant gradient shows that it's traveling at a constant speed. So it's on a straight line and it's a constant gradient. That means the object is traveling at a constant speed. If a graph has a horizontal line, then the object is not covering any distance and it is remaining stationary. Okay, and then I showed you guys a graph, and we discussed two objects, two cars, a blue car and a red car, and we showed one being stationary for a while and the other moving, and then the red car overtaking and then the blue picking up speed. Is there any questions that you guys are stuck on in terms of a travel graph? Okay. I'm just going to see if I can't work out one more with you guys. Okay, guys, what we did today basically just covered speed and time, distance and time. So we worked on the horizontal and the vertical axis, and we also discussed that if it's something constant, if an object is supposedly on a straight line on a horizontal axis, we know it is moving nowhere. It's a stationary vehicle, or stationary object. So please don't forget that the motion of an object, we said, is displayed in a distance time graph. Okay, the motion of an object can be displayed on a distance time graph. And if an object is traveling at a constant speed, the distance time graph is a straight line. Okay,